started recording, and yeah. Okay, so to start today's lecture, I would ask all of you please to have a fresh notebook and make sure that you upload these two files into your computer or Google Drive. It's up to you where you want to sort of pick this up from. But yeah, the fly and the tip data, please have them in your computer at least. And can I just ask everyone to have your microphone on mute, please? Yeah. All right. So now we can go and start our work. All right. Okay. So let me just see. Is everyone okay with having the files on their laptop or PC or whatever hardware you're using? If you have an issue, let me know. Otherwise, I'll just give another minute for you to ensure that you have the files uploaded into your computer. So first thing first, I'm going to say, let's get the two practice Excel files into our Colab environment. Yeah. Oh. Okay. So we are going to do that by opening this folder box here. So we go and open this folder box. I have already done it, but the way if you want to upload from your PC basically, or your laptop, you just click this upload, so you click that and it tells you what file to go and upload. For example, I've chosen these two and you just say open. So I've already done it, but you would need to, I guess you have done it in your downloads folder. So you just click on it and you click open, okay? And then they appear here in your file environment, basically file management of your Colab. Now, once you have that, okay, the files are here, but we have not opened it in our, code section. So the files are available, but we need to now bring them into life, sort of, so that we can work with them. And to do that, we are going to be using Pandas. So we will use Pandas to open the files as data frames. Okay, that's what we will do. Hence, we need to import Pandas. And to import Pandas, all you need to do is you say that import Pandas as PD. Okay, so this is importing the Pandas library. Okay, he's waiting now. Okay, now that we have imported Pandas, we can actually go and start importing these data as data frames. Now, the way we do it is that we're going to create two data frames. One is, well, let's just start with the tip data, yeah? So I'm going to call it tips, okay? Well, you can call this anything, yeah? So you can call your data frame whatever name you like. But on this occasion, I'm going to call them tips. So I'm going to say tips, and it's going to be equals to panda, which I've imported, dot read Excel. So I'll come down here. Yeah. Yes. Yep. It is there. Yeah. No problem. No, that's fine. That's okay. Okay. So pandas dot read Excel. Now I'm reading Excel because the files I have are Excel. Obviously, if you're using other sort of file formats, yeah, you would do read, for example, if you have CSV, you would be reading read CSV. But we are having Excel, so I'm reading Excel file. So read Excel, and you open the parentheses, and what you need to do is you go on the tips data, you take your mouse over there. Yep. Sorry, say again. Okay, so you go look in the Google Colab. Do you see this folder icon on the left? Do you see it? Jordan. All right. Well, just as I said, you open this folder icon, okay? You go and click this icon, yeah, upload to session storage, yeah, you click that, and it opens up. Then you choose from in your PC wherever you have downloaded them two files from the VLE. You go and select them, and then you press open. That's how you do it, okay? No problem. And the files are in your VLE. Have you imported them from the VLE into your PC? Good, good. So that's how you do it. Okay, no problem. Okay, so tips data. I'm going to call the command pandas.readExcel. Okay, and then you have parentheses. Now, what you put here, you're going to put the address of that file. So I'm going to say copy path. Yeah. So right click, you take your mouse on tips, right click, copy path, and you come here. All right. Now it's very important. Please pay attention. When you want to do this, you don't come and say, oh, because I've seen students doing it. You don't do it like this. Yeah, this won't work. Okay, so if I do this, I'm going to get an error. It just doesn't work. What you need to do, you need to ensure that this is in the form of, sorry, this is in the form of a string. So I'm going to put that. Okay, so I'm going to put a note here. Put the file path of your choice of file as string in the parentheses, yeah? Okay, as a string, important. So I'm going to do that, and now have imported tips, okay? Now that we have tips here, there are some, as I said, I don't want to focus too much on pandas. I want you to get introduced to it. So if you just quickly call tips, you will open a snapshot of the data frame for you. Now you can see that you start from row 0, 1, 2, 3, 4, and then suddenly you got these three dots, and it goes to 239, 240, 241, 242, 243. Okay? This is just a snapshot. Obviously, for 243 rows, it's not going to show you the whole thing. It's just showing you the first top 5 and the bottom, and sort of 5 rows of your data frame. Now, first thing first, always when you open your data frame, always try to have a pause and take a look at your data and see what does it tell you. What is this about? Okay, this is really important. And obviously, for these lectures, I'm using simple data so we can be, comfortable in terms of understanding them. So first thing first, you take a look at your data frame and you would try to make an assessment of what is this about. Obviously, if you're working in industry or if you are part of a project, they would provide you with some information about the data frame. Definitely, you will need to read that. So if there are any instructions or notes on the data, you have to do that first so that you understand what it's about. But then also when you open it up, it's important that you try to sort of make a quick assessment of it. So let's just go and do that together. So as I can see that just like an Excel sheet, yeah, I have a data frame and I have some columns. So that's one is called unnamed 0, total bill, tip, sex, smoker, day, time, size. Okay. First thing first, I definitely think that this doesn't mean anything to me. Okay, so unnamed, it just is following the index columns. So there is not much information embedded in this. It's just the way this Excel sheet, is structured. Hence why I say always try to check. So we definitely don't want this unnamed. That is useless to us. Let's look at the other stuff. We have a total bill. Okay, bill and tip. Quickly, we make an association. Where is it that you have a bill and you pay tip? It has to be a restaurant of some sort, yeah? And then we have the sex, female, male. Okay, so this should refer to a customer paying some bill and then also paying some tip. And then we have info as into if this customer is male or female. Okay? Then we have a smoker. Okay, smoker. Definitely, this indicates if the customer is a smoker or a non-smoker. Day, sun, sat. So this should refer to the day that the customer visited the restaurant. Okay? And time, it's a dinner, dinner, dinner. Okay, so far we just see dinner. Okay, maybe there is lunch or something in between as well, but we just take it as it is. Size. Okay, size 2, 3, 3, 2, 4. This should ideally refer to the size of the party, how many people there were. So this indicates that two customers entered the restaurant, dinner time, on Sunday. They were not the smokers, and whoever was paying the bill happened to be a female. Okay, they spent £16.99 and they paid a £1 and 1 pence tip. Okay, so that's what this tells us. So we can make an assessment of, all right, we are dealing with some data from a restaurant, and in this restaurant, basically, we have information such as total bill, how much tip they paid, whether male or female, a smoker, how many people came, basically, were in that party, in that group, who paid the bill. So we have our initial assessment of the data frame. We have some idea of what it's all about. Okay. Now, with Pandas itself, you can go and explore this further, and that's what we will do next week. Expand on our knowledge of Pandas. Yeah. But this week, we try to use another library, which is called Seaborn. Okay. And Seaborn is primarily used as a tool for visualizing data. Okay. And I have to tell you, okay, that Seaborn is amazing. Yeah, it has a lot of capabilities, and by no means I or anyone would be able to sort of go through everything it can do. I don't even know everything it can do. Yeah, so it's vast. Yeah, but all I can do this week is to introduce you to Seaborn and get you rolling. Otherwise, then it's up to you to go and further expand on your knowledge, yeah? Because it's almost limitless what you can do with Seaborn, yeah, in terms of visualization. So we will dedicate today, I mean, like you sort of learned, you got familiar with the data frame using Pandas, importing Excel sheet. For the moment, I would say that's enough with Pandas for this week because I would expand on it extensively next week. But we are going to now use Seaborn and its capabilities to see how we would visualize the data. Because data, I mean, in its form as a table, when you look at it like this, it doesn't tell you much, okay? It's the visualization using graphics that gives you the story of the what is hidden behind this data. Now, obviously, this is a really small, basic, made-up data frame, but you will see that even with such a simple data frame, once you start to visualize the stuff, yeah, then it makes a lot of sense. Now, also there is one pandas command that I would like you to learn, and that is tips.head. Okay, tips.head gives you the top 5 rows of your data frame in a nice, tidy manner. Obviously, you can put a number here to have like more rows basically shown, but by default it will show you 5. Yeah, so tips.head does that basically. It just gives you a snapshot of the top 5 by default, or whatever number you specify here. Obviously, if you increase the number, it would go into the same mode as hiding, the extended data for you. So now, as I said, we don't like this thing. We don't like this unnamed. Yeah. One way to, once we have imported this, yeah, this is important that you don't do this right from beginning. So you always import your data as it is, okay? Then when you identify that, okay, there is a column that is useless or you don't want it, in this case, we could use index column equals 0 to get rid of this, yeah? Or we can just do a drop. So I'm going to say tips dot columns, yeah, okay, so we can see the name of the column. This is a pandas command, yeah, pandas command to give you the list of your column names, okay. And it's very important that when you want to call these columns with pandas, you do exactly identical text, yeah. The way to drop this, we are going to say, I mean, as I said, I will cover these further next week, but let's just tips um, dot drop, okay, not drop m, drop, and I'm going to give that. Let me just do that for a second. Oh, what's he talking about? Just a second. I didn't spell that right, didn't I? Unnamed. That's definitely right. So what did I do? Oops. Oops. I'm being silly now. Not found in the axis. Have I? Let me just see. Is tips.column definitely? Oh. Okay. Sorry, I forgot to put the axis. Yeah. All right. So the tips.drop unnamed, which is in the column. Now the axis, I'm just using this use axis to refer to a column being dropped. So dot drop basically drops that column basically out of your data frame. Now there is a flaw you need to be aware. What I did here, it dropped it, but it didn't drop it permanently. It just dropped it and showed me a snapshot of it being dropped. Okay, so if I call tips again, okay, tips dot head, you will see that the unnamed is still there. Okay, so I'm gonna say, so as we can see, the unwanted column is still there. Okay, and I'm gonna of course leave this here so that we can compare. Now the right way of doing it, if you want to permanently get rid of it, is to do in place equals true. Okay, now if I call tips dot head, there we go. All right, so now our tips data is basically cleaned out. All right, So I wouldn't try to show you any more operations with pandas. I'll just leave it to this for the moment. So now we can go on. Now that we have clean data, okay, we are assuming that it's clean. Let's go and play with Seaborn. Okay. Now, first thing first, to use Seaborn, again, Seaborn is not a inbuilt Python function. It's a library that you need to import. So we're going to say import, okay? So we're going to say import Seaborn. Have I spelled that right? Yeah. As SNS. By convention, I mean, you can import it as Mickey Mouse if you like, yeah? But the idea, like conventionally, you import it as SNS. That's what it's called. Like everybody does that, yeah? So we are importing Seaborn as SNS abbreviated, yeah? And once I do that, it takes a little bit of time and Seaborn is imported, okay? Now we can go and try to see what we can do with Seaborn. First thing we're going to do, the first thing we are going to do is to see some distribution plots. Okay? So first thing first. Now you might be like, okay, what are distribution plots? Well, without me explaining, let's just go ahead and basically see what this is, like what it's all about. So I'm going to say, I'm going to call Seaborn SNS because I've already imported it, yeah? I've seen a student sometimes skip this, they don't import it and they call SNS. In that sense, SNS doesn't mean anything, yeah? So make sure you have imported it here. SNS.thisPlot, yeah? Which stands for distribution plot. Okay? Okay, this plot what? Yeah? What are we going to this plot, basically? Now, we are going to this plot one of the columns, numerical columns associated with our data frame. Okay? So if I go here and I say tips, just take a look at this. If I say tips, and I open brackets, yeah, and I put, let's say, total bill, okay? So let me just run that and see what do we get. So if I do tips, brackets, total bill as a string, as you can see, it goes and fetches that particular column for me, okay? So that's what calling the data frame brackets and name of the column does. It fetches that particular column for you. So what I'm going to do, so this is one of our columns and how we call the column out, okay? So now that we know we can fetch these columns like that, let's go and see if we can see a distribution of our total bill. Yeah, so we're going to say sns.thisPlot. And what I'm going to put here is exactly that. Okay, so I have SNS, this plot what? This plot the total bill. Okay, okay, and that's what you get. All right, so straight away it gives you the distribution information on your total bill data. Okay, so you can see that it has filled this with a certain number of bins. Okay, now I will be like also showing you a bit of how to decorate this, but I'm not going to go through all of these. I really expect you to get interested enough to go and explore Seaborn on your own sort of time. But there are ways that you can, of course, manipulate this in every way. One way of doing it is to come and say, I'm going to just repeat this, yeah? So I'm exactly repeating. So this is, let me just write a comment here. Let's try to visualize the distribution of our total bill. What's the total bill? Yeah, total bill. Now, we have already done that. How can we make it a bit more cool? As I said, what we refer to these bars basically is bins, yeah? So if you want to increase the resolution of your distribution plot, you need to increase the number of the bins because by default it comes with a certain number. So if I come and say, comma, bins equals 30, let's say. Let's see what do we get. All right. So as you can see, it goes and does the same thing, except that now you're having a higher resolution. Okay. So it's like as if it's trying to give you more detailed information. Now you might ask me what's the ideal number of bins to choose. Well, it's up to you, and it's up to your data and how it would look good. Obviously, if I can't choose something crazy like, 100 bins, well, let's do that actually in a separate one so that it's recorded here. So if I come and say this plot and I make this 100, because sometimes people have this idea that, okay, the larger number is better. Well, technically speaking, I don't know, does this seem right? Is this what you need? Does it meet the requirements of your project or what you want to do? Sometimes it may, sometimes it may not. Okay. Now, for me, I think this is ideal. Yeah. Even the, smaller number seem to be okay as well. Yeah. But that's how you basically control it. And again, it's case specific. It depends on how you want to present your data, but that's how you can control it. Okay. Uh, you can also add a kernel distribution estimation to this. Yeah, so let me just go to this, the one that we did with 30. So I can come and say, okay, so bins is there, and I'm going to say KDE equals true. Okay. Okay. So if you like, you can also add a kernel distribution, sort of function, basically showing this, the estimation function, showing you the distribution, of the data. So it just tries to sort of give a more smooth projection of how your data is basically being distributed. And you do that with KD equals true. Otherwise, if you don't refer it to as true, by default, it will be in the false format. Okay. So that's our tips. Yeah. Now, obviously, again, because of time constraints, we are just going to look at this. But I hope that after this, you can go and play about with the different columns. Yeah. So I tried this column. So I'll put this as a homework for you. At this point, after lecture, go and play with the other columns and see what you get. If you get an error, then try to search the net. This is really important on why you are getting an error. Okay. And if I want to give you a hint, well, think of your columns. Yeah. Some of your columns are numerical, some are categorical. Yeah. Bear that in mind. Right. But then, yeah, definitely go and look at this distribution. Now, let's look at another way of visualizing data. And we are going to do that by looking at what's referred to as a joint plot. Yeah? Okay. So we're going to look at a joint plot. Now, again, prior to me explaining what a joint plot is, we're going to just run it and then see what it gives us. So now let's explore joint plot. Okay. Oh, why did I do that? With the joint plot. Okay. So like we called SNS dot this plot, the joint plot, SNS of course, because it's part of Seaborn, and we're gonna say joint plot. Okay. Now joint plot, as the name indicates, it is joining something. Okay, it is joining something. So shall we say, shall we? I'm just hoping that you sort of think in this way. Yeah, you probably are like, okay, joint plot. Let's just try joint plot, as we did before. Would this work? Let's see. So joint plot that. Yeah, let's see, what do I get? Is this telling me anything? No, I didn't get an error, but what sort of information is this giving me? Nothing really. It's quite weird actually. So I have total bill here on the y-axis, and on the x-axis, oh, there is an x-axis. What I'm having, what? None. And then I seem to have some form of a distribution plot here, okay? And some, data that doesn't make sense here. Well, that's because joint plot is designed to jointly plot two separate columns with each other, okay? Hence, what I would say we need to do as well is to go and pick another one of our columns, yeah? So instead of doing that, actually, let's do this. Now that we have understood that, okay, we need another column, like to sort of work with. So I'm just going to call tips dot head, okay? All right, so what do we want to see? Joint plot. Okay, how about total bill and tip? Shall we do that? Yeah, let's do that. Okay, and the way you do it is that you put your first chosen column followed by your second chosen column. Okay, so I'm going to call tips. Okay, and this time tips tip actually. Okay, so just in case I don't want you to get confused, what is tips tip? Uh, just give me 1 second, guys. Tips tip. Okay. So, as I said like before, it goes and fetches our tips column. Okay. So let me just get rid of this. Now I have tips total bill and tips the tip basically. All right. So I'm going to join these two together. Let's see if it works. All right. Join plot takes from 0 to 1 positional arguments, but 2 were given. Okay. So this now might seem a bit confusing. I mean, what happened? So we thought like, okay, this should be working. So why we basically got a error basically coming up. Now, the main reason that I pushed you through this, like was sort of getting you right from beginning, get an idea that the correct way to do this, because usually when you make error, you become more sort of what do you say, enthusiastic about finding out, okay, what went wrong? What did I do wrong here? So what you need to do, yeah, is you just get rid of all that, right? And we're going to say x equals total bill, okay? And then we're going to say y equals tip, yeah? Fine. But just a second. If I do this on that, yeah, it's going to say what? Could not interpret value total bill for X. Value is a string, okay? I'd like you to read these sort of errors and see if you can try to make a sense of it. Value is a string. Well, of course it's a string because, total bill, how would it know to go and fetch it from that data frame? This is where you actually go and say data equals tips, yeah? So you give the name of your data frame, then you say what you want in X and what you want in Y. And once you do that, okay, you get this popping up, right? Now, let's now look at the information embedded in this plot, yeah? So on our X-axis, as we said, we have the total bill, and in our Y-axis, we have the tips, yeah? So and they are basically ranged within their own sort of actual range. So 2, 6, and then 10, 50 total bill. Take a look at these guys, especially these two distributions. Yeah, that in fact is the distribution plot. Yeah, that's the distribution plot of your total bill. Have we seen this before? Well, yeah, but with a more detailed number of bins. Okay. So in a sense, joint plot does two things at the same time. It gives us a snapshot of our distribution for this particular column and the distribution of our second column here. And now here it demonstrates the relationship. It demonstrates the relationship embedded between these two columns. How do you interpret this? Well, take a look. When we have a total bill of between 10 to 20 or 30, okay, we can see that our tips are falling within sort of maybe what around $2 to $6 or pounds or whatever unit that is, yeah. So in a sense, it's telling us that just looking at this, if a certain bill comes in, how much tip do you usually expect from it? So from 10 to 20 or 15 pound, you can expect to have a tip of around 2 to 4 pound. Obviously, you have outliners, like that, yeah, or like that here, or like this one here. I mean, this guy has spent what, 8 pound, yeah, and he has paid around 5 pound tip. Proportionally, that's almost as if he has almost paid the same money as tip, as what he has spent. And you got this guy here who has spent 30, maybe £5, as his bill, and he has only paid, £1 tip. Okay, so you always get these outliners and exceptions, but usually, and remember, this is just some 400 data points or so, yeah? But this is supposed to tell you a quick snapshot of, okay, what is happening, how is our data, what information is embedded in the data. Yeah, and joint plot is fantastic. So let me just write here, fantastic tool to swiftly compare, two columns of our data and see how they relate or interact. Yeah, basically that's what it does, right? Now there is different ways of decorating this. Yeah, so we can decorate this, and we are going to now do that exactly. We can decorate our joint plot in different ways, and we do that by, well, let's see how do we do that. Yeah, so I'm going to just exactly repeat this. Yeah, I'm going to exactly repeat the same thing. Yeah, and I'm going to add another parameter, another argument into the function. Yeah, and that is going to be kind. Yeah, Now this kind obviously doesn't mean that there is kind or angry or anything. The kind means what type. How do you want this joint plot to be visualized? There are certain key factors that you can give to it, and it would change the design. So I'm going to say hex, and it will go and do exactly the same thing, except that it would use these hexagonal bins, and it will sort of make them darker the higher the density. So technically, it's doing the same thing. It's doing the same thing, but it sort of generates hotspots in form of hexagons. So this, when you look at this, you can tell that, oh, that's a hotspot. That means you have a lot of occurrence here. When you have such a high occurrence, it sort of gives you an indication. Basically, the darker the color is, yeah, it gives you an indication that it's more reliable, that relationship in a sense. Yeah. I mean, apart from a statistical analysis that you may need to do separately on your own sort of time, yeah, independent of just basic visualization. But this right away tells you that, so in this restaurant, in this particular restaurant, it seems that spending between 10 to 15 pounds and getting tips of around maybe £1 to £3 or £2 is the norm, okay? Because you're getting these dark sort of highlighted bins in your hexagonal joint plot. Whereas with this, maybe it was not as elaborated. And outliners, meaning exceptions or data that you don't really rely on, basically are going to be really pale, yeah? So that's one way of doing it, and you do it with kind. There is another way of, again, visualizing this, yeah? Another way of visualizing this. And that is going to be, again, we use kind to visualize that, like to change the method of visualization. You can have a regression plot. Let's try that and see what do we get. Okay, so let's take a, so still, we always get the distribution plot by default. Okay, so we get the distribution plots of each column by default. Here we also have a KDE, yeah, on the distribution plots. But take a look. So we have our spots, basically, we have our scatter dots in place, but it tries to fit a straight line. Okay? It's trying to fit a straight line. Now, I'm hoping that you know what a regression is and what is a regression line. So it's trying to, this command, it will go and perform some calculations and will try to see if I can fit, best fit a straight line between your columns. Now, mathematically speaking, this is very important. I mean, here, we can tell you cannot really define the relationship, yeah? So you cannot generate a mathematical relationship where like give the total bill and with certain confidence it would predict the tip, yeah? Because we don't see that form of linearity, yeah? But it still will try to generate a straight line for you. In other words, it will carry out a regression analysis. And it will try to sort of demonstrate like if your data follows a linear pattern of relationship. So it's quite useful. So I would say this gives some statistical mathematical flavor to your data visualization. Okay? Very important, especially if you want to know that should you sort of put some time and create a regression model between these two, right away doing this is a good indication that, okay, is it worth it or is it not? Yeah, think of it like that. Now, let's look at another method. Well, we're going to call it pair plot, okay? Pair plot. Let's look let's look into it. Okay. Now, what's a pair plot? You might be like, oh, Ali, a joint plot, pair plot. They seem the same. Are they doing the same thing exactly? You know, like is pair plot like the same as a joint plot? Well, don't get confused. I mean, I know the name may push you into thinking like that, but in fact, a pair plot means doing a pairwise comparison, sort of. Okay, pairwise, but let's try it. Let's try and see what do we get. I can tell you that it's not going to give you this, but it's going to give you, in fact, a lot of important information as a data scientist. Yeah, so let's call it SNS, and we're going to do dot pair plot. Okay, SNS dot pair plot. What do we give here? I hope, well, we don't have enough time, for me to just go again, type in wrong sort of stuff so that we can get an error and like see what comes. All right, let's cut the chase. SNS.pairplot, you give the entire data frame name to it. Yeah, so I'm going to say tips. So you give the name of the entire data frame into the parentheses. Yeah, so the function takes in your entire data frame. All right, that's pretty good. So you just give the whole lot to it. But what does it do for us? Yeah, let's see. Now, I hope you also appreciated that it took a bit longer. I will emphasize on something, but let's first see what did it do. So on the x-axis we have total bill, tip, and size. Okay, and what do we have here? Again, total bill, tip, and size. Now, if you notice, firstly, how many columns did we have, guys? How many columns? Hold on, let me just write this here. Hold on. Did we only have 3 columns in our data frame? Did we? Let's just double check, So tips dot head. Oh no, what did I do? Tips dot head. Sorry guys. Tapis. All right. No, we definitely have more columns. We have 1, 2, 3, 4, 5, 6, 7. So why is it all 3? Only 3, like is represented here. Shall we take a look? So total bill is there. Tip is there. Oh, sex is not there. Smoker is not there. Day is not there. Time is not there. What size is there? Okay, what's the difference between the columns that are appearing here and the columns that are not? Well, sex, smoker, day, time, these are categorical. Okay? So we see that the categorical columns are not present, but the numerical columns are present basically in the visualization. And that's exactly what the pair plot does. So what's happening? What is happening is that pair plot will only go and fetch your numerical columns and not the categorical ones. Very important, guys, yeah, to appreciate this, that it's basically going and only fetching you numerical columns. But fine, okay, we understood that. Let's see what does it give us. So it's exactly trying to demonstrate the relationship between your data together. Now, as you can see, this is total bill with total bill. Yeah, total with total bill. Obviously, it is perfectly correlated. So total bill is perfectly correlated with itself. So there is no point in plotting this because you're just going to get a perfect straight line. But instead, it will put the distribution of it for you. Okay, so you get a distribution information of your total bill. But when you compare total bill to tip, it will give you that. Yeah. Of course, you get tip to total bill. Have you noticed something? We already looked at this, yeah, earlier on with our joint plot. So in a sense, the pair plot is a fantastic tool to give you a swift, straight away snapshot of the relationships and correlations between your columns. Now you might be like, why would I want to know that? Well, that's the fundamental pillars of data science. Is sometimes you want to know if you have columns which are colorated when it goes to training machine learning models or whatever. Do you want them to be colorated, or do you even, or you don't want them, or are you interested to know which columns are correlated with each other? Yeah. So this gives you that information with a single short, I mean, look at that. Yeah. With a single quick command, it gives you all that information. What I want you to understand, and it's really important, at the moment, let me write this here. Yeah. But be careful. So let's do this. But be aware. If you have a huge data set, yeah, and I don't mean number of rows, I mean number of columns, yeah. If you have a data set with large number of columns and you have a big data, this can take, I mean, with my own data, I have had sometimes 30 minutes, yeah. This can take 30 minutes to be calculated or generated, at which point you may run out of RAM, well, memory. This happens, yeah? So be aware, if you got a really, really super uh, data, I mean, literally, if you have up to like 5, 6 columns, there are 10 columns maybe, yes, okay, you can do it. But once you go with complex data where you have like 120 columns, uh, you need to appreciate that it needs to go and do all these calculations for every single column with respect to the other column. And even when it generates it, it's going to be, everything is going to be so small because, like it needs to embed all of this information there that the whole thing is becoming pointless. So you use a pair plot, which is a fantastic tool of giving you a snapshot of what's going on, what's the relationship, is the correlation between columns when you have a moderately manageable data set. Otherwise, you're better off to go with individual sort of selection. Yeah. Now, one of the cool things you can do with this as well, yeah, with the pair plot, especially when you have categorical columns. Remember, we had numerical columns only participating in this generation of this image, yeah, but we had categorical columns as well. So, you know, let's just say, okay, cool. But how about our categorical columns? I mean, they hold some info for us. Yeah. So what do we do? Okay. Now, the way you do it, okay, of course you can't plot categorical columns like this against each other, but what we're going to do, we're going to exactly repeat the same code. So it's exactly the same thing, guys, yeah? And what you can do is you can then add another parameter which is called hue. And in this hue, okay, let's just look at our categorical columns. Let's just put a code here, and then I'm going to say tips dot columns. Yeah. Okay, so sex, smoker, day, time, they were different, yeah? Shall we say hue, and I'm going to choose sex, okay? Because that's a categorical column. There is no value to it. I mean, you're either woman or man or female or male, basically, whatever. So if I do it like this, let's see what does it generate for us. Okay, that becomes more exciting now. Let's compare. So here we just had those distributions. Now it is giving you the same thing. It's giving you the same thing, except that it's identifying for you the distribution separated between male and female, which gives you significantly more information. Again, with this example, this is quite basic, but it's now telling you what the relationship between total bill and tip, yeah, when you consider men and women. Do you see more correlation in the orange ones compared to the blue ones? Well, maybe. I mean, of course, like you don't see it here, but it is possible as a data scientist, you will suddenly notice that given a categorical feature of your data, then you suddenly see a correlation. Whereas for a other category, you were not seeing it. Hence why these methods are basically fantastic to use. Now, there is another parameter you can add as well, which is called the palette. Yeah, that sort of selects the style of the color, and I encourage you to look into the Seaborn website just to see what other sort of colors you can see. I think cool warm. Let me see. I think there was a plasma. Let me see if that works. It might give me an error or will it work? Let's see. Okay, so that's plasma. It just changes the color. So female and male are changed separately. And then there is, let me see if there is magma. There's loads of these, yeah, maybe like 30, 40 different styles, yeah, but I mean, like, that you can choose. And then there is, I think, cool warm. Okay, you can explore this on your own, whichever suits you best. So this is blue and sort of reddish or orangish again. Okay, but again, I hope you understand that this gives you some fantastic information, as a data scientist, especially when you're going through the data pre-processing step. Yeah, when you want to explore your data, there is this rule in deep learning, machine learning, AI. You need to become one with your data. Meaning, as a data scientist or an AI engineer, you need to become so familiar and at home with your data. And you only that happens, when you do extensive data pre-processing and understanding of your data. And Seaborn has a lot of these features, in terms of visualization to give you a fantastic set of information prior to you doing any machine learning or deep learning or whatever, to have a snapshot of your data, becoming one with your data and knowing, oh, what is this? I mean, like, what is my data telling me? Okay. What else do I want to show you before we finish today? Let me see. So let's just do a bar plot as well, because we said categorical, yeah? So, and I'd like you to go and try to use different categories, yeah? Different categorical columns. And I mean, like, for example, I can put a smoker here, yeah? Okay, so a smoker and non-smoker. So smokers, yes, are the orange ones, and non-smokers are blue ones. I mean, one way of interpreting this, it seems maybe looking at this orange color that, I don't know, do the smokers give more tip or non-smokers? Can you sort of extract that information visually from this? These are the sort of things that you can explore. Now let's quickly look at bar plots. Yeah, bar plots we are going to look at. plot. Okay. Now I actually wanted this to be bigger. Now bar plots are, I mean, I'm sure you have seen these in Excel and everywhere, but yeah, so they are perfect for categorical sort of column. So bar plot, and we're going to give x equals sex. I think, yeah, that was one category. And the second one, so one of them is categorical. The second column, I'm going to give y. It's not going to be categorical. I'm going to say total bill. Okay. You might be asking me, Ali, can we do a categorical there as well? Well, I'd like you to try it after this. Yeah. And again, guys, just before I do it, yeah, before I do it, if I run this, I'm going to get an error, obvious, and it's going to tell me it's a string or something. Look at that. Could not interpret value 6 for x. Value is a string. Well, of course it is. Because if you just say x equals 6, that's a string. It has nothing to do with any data. It's only after you come and say data equals tips. So just as a reminder, I know we discussed this earlier on. Oops, and then what went wrong? Does not appear in data. Did I? It's all right. That's interesting, guys. It's my mistake. I've done a mistype, but look at that. I've just typed total bill by mistake. Yeah. So there is a L missing, right? So it's very important that you call the column names exactly as they are. So you do that and you get a bar plot basically. So here it's now telling you total bill, male, female. Okay. So in the x-axis we got our categorical column basically, which is male, female. If you add more categories, you will see that as well. And in our y-axis we got the numerical, which indicates how much bill they paid. So here we can see how much the females paid, how much the males paid. It seems in this particular restaurant you can interpret that, okay, seems men are spending more in this particular restaurant. Maybe it's more men friendly, or like men prefer it, or less women maybe go there. I don't know. Women don't want to spend that much money there. Well, we don't know. Yeah, like you see this and then you go and explore. Okay, and I think. I think I'm going to leave it to that for today. But as I said, because I will be dedicating the coming weeks to pandas, and through pandas we will do loads of these. Yeah, I think this is a good introduction for you today to have a flavor of what pandas was all about. Well, it was really basic what we touched on pandas, just opening a data frame, really basic stuff, and some capabilities. This was a fraction of what Seaborn can do. We will introduce you to a bit more of the techniques, of Seaborn. But for today, I think that's enough to get you going and, getting you sort of on the roller coaster. Okay, guys, so I'm going to end the lecture at this point. Please go and try to play with these codes, yeah? Try to mess about and try to see, like how you can manipulate it. And definitely go on, Seth Seaborn's website and try to see what other tricks are there. If you like it, especially for your final year dissertation, for your courseworks, whether you're an engineer, you're a psychologist, I don't know, you're an electrical engineer. I'm sure you get a lot of numerical or categorical data. So now I think you can see that you can use Seaborn, even if you're not using it for data science, sorry, for machine learning, but you can do some perfect, fantastic visualizations with it. Okay, so yeah, I think it's better to end it now. And I do apologize that I started late because I had a home emergency. There was nothing I could do. My daughter got to be ill and I had to take her to hospital. Not hospital, doctor, sorry. Okay, so if you're all okay, I'm going to end the lecture. And as usual, I'm going to be sharing the code and the video lecture for you later. No problem, guys. Have a pleasant evening. Fantastic. Thank you very much. And I see you next week. Great, guys. Thank you. Take care. Let me stop the record.